Hello everyone. Today our group will be presenting a forensic case study titled A Case Study on Bali Bombing. This case highlights how forensic science play a crucial role in one of the most devastating terrorist attacks in Southeast Asia and how international cooperation contribute to both victim identification and criminal investigation. The members involved in this presentation are myself, Dalili Fahimmah, Cik Nur Amanina, Siti Iwani, and Nur Izzati. Each of us will cover different aspects of the forensic investigation. Here is the outline of our presentation, starting with introduction, Operation Alliance, crime scene investigation and the breakthrough, types of explosive, analytical chemical technology, confirmatory instrumental technology, and conclusion. And I will begin with the first two sections. On the 12th of October 2002, two bombs exploded in Bali, Indonesia, causing massive destruction and loss of life. The primary explosion occurred outside the Sari Club in Kuta, a popular tourist area, and resulted in a deep crater and widespread fires. A second explosion occurred around 10 kilometers away. In total, 202 people were killed, and more than 200 others were injured. This tragedy was one of the deadliest terrorist attacks in Southeast Asia. To manage the complex demands of this case, a joint operation was formed called Operation Alliance. This was a multinational collaboration between the Australian Federal Police, the Indonesian National Police, pathologists, chemists, and forensic scientists from both countries. Their objective were to identify all victims accurately using forensic science, collect and analyze physical evidence from the blast site, and establish reliable forensic links between the evidence and suspects. The role of forensic science in this case was not only important, it was essential. The FFP responded quickly by sending forensic specialists to assist in Indonesia. From the start, the FFP established a mobile laboratory on site. This mobile lab allowed investigators to process large numbers of samples efficiently, provide critical information to investigators almost immediately, and support the disaster victim identification process in real time. The success of this operation also highlights the growing need for portable field instruments and better support for emergency forensic. The forensic team was diverse and highly specialized. It included DNA profiling experts, explosive and residue analysts, crime scene investigators, pathologists, and disaster victim ID teams. The mobile laboratory set up in Bali allowed the team to conduct on-site testing. Preliminary results could be shared with investigators in real time, even before confirmation from the main laboratory. This rapid response greatly improved the efficiency and impact of the investigation. The close cooperation between Australian and Indonesian authorities led to multiple breakthroughs in this investigation. For example, TNT and chloride compounds were identified, vehicle chassis and engine numbers were recovered, and DNA profiles were matched with high accuracy. The forensic findings directly contribute to the early arrest of the key suspect. This success demonstrates how forensic science, when combined with international collaboration, can deliver justice and provide closure to victims' family. Next, let's go into the crime scene investigation.
Hi, my name is Siti Iwani binti Imransya, and today I will cover about the crime scene investigation and the breakthrough. Let's go through how the investigation, the crime scene, and use the evidence to build a strong case. Let's start with the first explosion at Paddy Bar. A man walked into the bar wearing a suicide vest. Inside the vest were 5 PVC pipes filled with TNT. There's a powerful explosion. The bomb exploded at about waist level around 80 to 120 centimeters off the ground. It was a horrible scene. Blood and the body tissue were found on the ceiling, showing how powerful the blast was. Now, hear how scientists figured out it was suicide bombing. They found a small pieces of the bomber tartan vest and lots of metal sharps in the area. DNA tests show that all the tissue and blood found on the ceiling come from just one person, the bomber himself. At first, investigators thought they had identified the bomber through his family, but the DNA did not match. Later, the same DNA profile show up again in the tiny body parts found near the Sari Club. This taught them something important. That was not just one suicide bomber. There was two. About 50 seconds later, a much larger bomb exploded outside the Sari Club. This was the deadliest part of the attack. This bomb was put inside a Mitsubishi van. It contained over 1 ton of chemical, including potassium chloride, sulfur, aluminium, and TNT. The explosives were packed into 12 plastic-filled cabinets, all wired together and boosted by PETN, a high-power explosive. This bomb caused a massive fire, destroyed buildings, and created a huge crater in the road. But the explosion created a big problem for the forensic team. The heat from the blast and the fire burned away most of the evidence. Then a broken water pipe filled the crater with water, washing away even more. But the scientists did not give up. They searched, protect spots like cracks in the road and behind lampposts, and still managed to find traces of chloride and TNT. That impressive, consider how much was destroyed. The third bomb exploded near the US consulates. About 10 kilometers away, it was much smaller and did not hurt anyone, but it turned out to be a key part of solving the case. This bomb only used TNT and the blast site was clean. Scientists were able to find explosive residue right away using a mobile lab set up nearby. This lab had special tools like infrared spectrometer and spot tests to detect chemical quickly on site. But here the real breakthrough. Investigators found a hidden number stamped into the van chassis, something most people wouldn't know about. Even though the terrorists had tried to fill off all unusual serial number, this hidden one survived. That number led police to a man named Amrozi, who later confessed and gave up the name of the other attacker. Now let's move on the major breakthrough in the investigation, the moment when everything started to come together. First, vehicle tracing. First, investigators focused on the van used in the Sari Club bombing. Even though the chassis number had been filled off, police discovered a hidden inspection stamp that was not commonly known. This led them directly to Amrozi, who had purchased the van and the explosive, and revealed the name of his co-conspirator, which is Samudra, Idris, Dulmatin, Muklas, and Ali Imran. This discovery was the first key step in unraveling the whole network. Second is linkage suspect. Next, Amrozi's confession did not just match the physical evidence, it also confirmed the chemical purchase and the bomb planning detail. More importantly, it helped investigators confirm the terrorist group structure, specifically linking them to Jemaah Islamiyah, or JI, a non-extremist group. A month after the bombing, another important lead came from a house search in Denpasar, where the bomb was believed to have been built. Here, forensic scientists found first microscopic explosive residue, specifically potassium chloride, sulfur, and aluminium inside flow vacuuming. They also discovered a barely visible footprint made of aluminium dust on a newspaper, which confirmed someone had been present at the scene. Finally, let's talk about the impact of forensic science in the case. Using DNA analysis through disaster victim identification protocol, scientists confirmed the presence of the second suicide bomber. Even more impressive, out of around 2,400 samples, only 6 show chloride trace, proving just how precise the sampling had to be. Multiple forensic labs worked together, including the AFP in Australia, FEL in the UK, and FPFSC, to validate the finding using advanced techniques like DCMS, SEM, EDX, IMS, and capillary electrophoresis, which is CE. This breakthrough shows how detailed forensic work, from hidden number to microscopic particle, play a huge role in catching the bomber and uncovering the truth.
Hi, my name is Izzati binti Ismail. To continue, before I go through the type of explosives involved in this case, let me briefly explain about the mechanism of an explosion. So, what is an explosion? Basically, it is an energetic reaction that results in the rapid release of a gas. Therefore, the rate of reaction determines the destructive consequences. The type of explosives can be classified into two general types, which are organic explosives and inorganic explosives. Organic explosives such as TNT, PETN, and RDX are characterized by high velocities of detonation up to 9,000 meters per second, whereas inorganic explosives like improvised explosives using inorganic compounds such as ammonium nitrate with fuel oils usually have relatively low velocities of detonation. Let's dive into the types of explosive involved, shall we? Firstly, Paddy's Fire Bomb involves between 1 and 5 kg of trinitrotoluene, also known as TN. Next, Sari Club Bomb, which is the main explosion, is an explosive mixture of potassium chloride, sulfur, aluminium, TNT that acts as a booster, and PETN, pentetritotetanitrate, which acts as a detonator. It caused the thatched roofs over the courtyards to catch on fire, and the blast broke a water main under the roadway, causing the crater to flood. That is the USA consulate bomb that is made from a relatively small amount of TNT that had been remotely triggered via mobile. However, no injuries were caused. Contrary to intuition, but accepted by most experienced practitioners, large explosions usually leave less telltale residue than smaller ones. Crime scenes where explosions have occurred are particularly challenging to process due to their complexity. Microscopic fragments of explosive and its residues will be spread throughout a large amount of post-blast debris. Therefore, analytical chemical technology and confirmatory instrumental technology is done to analyze the post-debris. Here are the main objectives of analytical chemical technology in explosions. It includes to quickly screen for the presence or absence of explosive residues, to guide forensic sampling and determine which samples should be prioritized for further testing, and to provide immediate tentative results that support early decision-making. There are two main groups of analytical chemical technologies used in this case. First one is the presumptive field tests, which are done as rapid screening for the presence of explosive residues. The different methods used as the colorimetric tests are diphenylamine test, grease test, Nessler's reagent test, aniline hydrochloride test, and alcoholic potassium hydroxide test. Following that, different mobile laboratory instruments were utilized as on-site analysis to guide sample collection and reduce sample backlog. The methods include ion mobility spectrometry (IMS), portable FTIR, and microscopy with camera.
For my part of presentation, I will be explaining the confirmatory instrumental technologies used in the forensic investigation of the Bali Bombing case. After initial field testing and sample collection, confirmatory techniques were essential to accurately identify the explosive materials. These technologies help forensic experts confirm the chemical composition and structure of the explosive found at the scene. Some of the confirmatory instrumental techniques used is gas chromatography, mass spectrometry, GCMS, FTIR, Fourier transform infrared spectroscopy, SEMEDS, scanning electron microscopy with energy dispersive X-ray spectroscopy, IMS, ion mobility spectrometry, and lastly, X-ray diffraction, XRD. Let's start with GCMS. Gas chromatography mass spectrometry was one of the main confirmatory techniques used in this investigation. It allowed forensic experts to detect and confirm organic explosive compounds like TNT, PETN, and RDX in debris and residue samples. GCMS is powerful because it combines separation of components with mass-based identification, giving high specificity and reliability in forensic chemistry. Next, FTIR, Fourier transform infrared spectroscopy. FTIR was used to identify functional groups in the explosive residues, especially nitro groups. This helped confirm the molecular structure of the explosive and FTIR may have been applied to various samples such as soil, bomb fragments, or clothing. It is useful because it provides a molecular fingerprint of substances based on their infrared absorption. Scanning electron microscopy with energy dispersive X-ray spectroscopy, which is SEM-EDS, it helped to examine microscopic particles and determine their elemental composition. It confirmed the presence of inorganic explosives such as potassium nitrate and also helped to identify detonator and circuit residues like metals from wires or plastic caps. These techniques combines high-resolution imaging with elemental analysis. IMS, ion mobility spectrometry, was used in the early stages of the investigation by bomb squads for rapid field detection of trace explosive. While it is not as definitive as GCMS, IMS provided fast results on site, helping guide where and what to sample for further analysis. This was critical in time-sensitive operations like bomb scene assessment. Last but not least was XRD, X-ray diffraction. XRD was used to confirm the crystalline structure of solid explosive residues like ANFO. It also identified metal oxides and salts in the samples. These techniques offer structural and elemental confirmation, helping forensic teams link residues to specific explosive materials used in the bombing. In conclusion, the 2002 Bali bombing case claimed 202 lives and prompted a joint international investigation under Operation Alliance. A breakthrough came through vehicle tracing and residue matching. The investigation used early field detection tools like IMS and FTIR for fast screening, followed by confirmatory techniques like GCMS, SEM-EDS, and XRD to identify explosive materials such as TNT, PETN, potassium chloride, and sulfur. These advanced technologies were critical in identifying the perpetrators and to ensuring justice was served. Thank you.